Okay, all right, let's do question 63 in chapter 12. This is sort of the follow-up to the last one where we were talking about concentrations. Now we're going to look at what's necessary to calculate, what we need to make a couple of them. And we're going to do an example that uses molarity. We'll do one with molality. We'll also do one with percent by mass composition. So let's get into it here. So our first example is 1.00 times 10 to the 2 milliliters. Okay, that is 100 milliliters with confidence in this zero here. And we want 100 milliliters of 0.500 moles per liter solution. And we're going to do that with potassium chloride. Okay, so moles per liter, this is molarity. So put that here just in case that slipped anyone's mind since the last video. Okay, so let's have a look at the game plan here. So each of the concentrations in a sense kind of, well, except for molality, but most of them kind of give you something easy here. In this case, the volume is sort of more or less taken for granted. We'll see after that it can't necessarily be assumed to be so, but if we do the order of operations all right, then everything kind of works out here. So what we have to figure out first is how many moles we have within 100 milliliters of this concentration. All right, so our first step is to calculate the amount of moles, right, of the solute in the volume that we're targeting. Right, and the target volume, this should be reversed, I guess. Okay, and then after that, we will just add, we'll convert this into mass. Actually, it's sort of assumed in this question that you're going to be given these answers in mass, like you're weighing them out, with a scale kind of thing. So we'll convert the moles to mass after that. Right, we'll convert moles to mass, and then we're going to be in good shape. After that, we just have to add whatever amount of solvent we need to make it hit 100 milliliters in a graduated cylinder. Okay, so let's make this happen. So moles of KCl in that solution. This is concentration times volume. We're going to have to change the units here. You see we're in milliliters here. So let's convert that to liters, right, which is 0.100 liters. We'll multiply that by 0.500 moles per liter. And you can see this is going to cancel out the volume. And we're going to be left with an answer in moles, which is 0.05 moles. Okay, so now let's find out what mass of potassium chloride this is. To get the mass of potassium chloride, we're going to multiply the moles by the molar mass. So there's going to be 0.5 moles. Multiply that by the molar mass of potassium chloride, which is 74.55 grams per mole. All right, and that is going to give us a total of 3.727 grams. So we're confident to 3 figures in both of these, so we're only going to be good to here. All right, so what we'd be doing then to make this happen, we'd be measuring out 3.73 grams, because that's where our confidence is, of KCl. We would dump this into a graduated cylinder. All right, it's going to be quite a cylinder here. So we would put this in there, and then we would just add water until the volume was 100 milliliters. So you see, this is going to consume some volume in itself, right? So we don't necessarily add 100 milliliters of water to it, but we add water until it is 100 milliliters. Okay, so that is molarity 101. It should be said, though, that 100 milliliter thing I said, that's technically the correct answer, but in practice, realistically, that's it's sort of assumed to be zero. Any solid species seem to have their whatever volume they consume completely made negligible in these calculations. So I'm sure you're not going to miss your mastering chemistry answers with that. Okay, next we are going to look at molality. So molality, we're looking for 1.00 times 10 to the 2 grams. Once again, we're looking at 100 with confidence there, grams of 0.50 molal potassium chloride. Same solute here. Okay, so the plan of attack is very similar, but it's a little bit different. So same. We start the same way. We want to know how many moles there are in 100 grams of this. Right. So number of moles within, and now instead of target volume, it's target mass. But the calculation is identical because we have moles over something, and we're just multiplying it by something to cancel the something. Moles within target mass. Okay, so then after that, we will convert the amount of moles. All right, I told you guys this was going to sound familiar. Moles back to mass. And once we've converted that back to mass, then we're going to find out how we have to calculate. This is our extra step now. Calculate the mass of the solvent that we would add to it, right? Yes. So then after we have to calculate the mass of the solvent. And that's like, the total mass that you have minus the mass of your solute. Right? Which in our case means like the mass of the KCl. Okay, so 3 easy steps, and let's make them happen. So moles of, these are the same numbers. These are going to work out to the same numbers as last time, but we'll go through the motions here anyway. Don't forget this unit. This M here is standing for moles per kilogram, right? Meaning we've got, again, 1,000 to 1 conversion to do between what we're given and what we need this in. So this is going to be 0.1 kilograms. All right, again, we got confidence in 3 figures times 0.50. We'll just write these out times kilogram. Cancel our kilograms to get moles, and we get the same amount of moles as last time, right? Same amount of moles means this is going to be the same amount of mass. So 0.05 moles. All right, we're multiplying that by 74.55. This is the molar mass of potassium chloride. All right, hopefully I'm not going through this too quickly. Okay, and then this is going to give us, again, same number, 3.727, but we had to round it to here because of the amount of figures that we have, so we round it to there anyway. Okay, so last step now. Last step is to calculate the mass of the solvent, right? So to prepare this solution, like, we have to weigh out the following. We're going to need 3.73 grams of KCl, and we're going to need 100 minus 3.73 grams, and this is because we have 100 grams total here, right? Right, of H2O, and this is going to be 7 and 2 gives 4, so it's going to be 96.27 grams of H2O, and that will give us 100 grams of 0.5 mole potassium chloride solution. Okay, last and definitely the easiest is mass percentage. And you notice if you're in the lab and you check out the bottles that they send, there's a lot of molal concentrations. Again, like, molarity is a rather treacherous variable. Like, it's because volume is variable by temperature and all that. I did mention it a couple questions ago, but molality is constant, but mass percentage is very easy to do the calculations from when you're working in weights alone, right? Which you are in a chemistry lab. There's no such thing as an analytical balance that spits out a number in moles, right? If we're weighing things, we're getting our numbers in mass. So in this case, they are asking for 1.00 times 10 to the 2 grams. Right, there has been a pattern in the numbers we got of 5%. 5% by mass. That's what this WW here means, by the way. That's like weight over weight, but this is the same by mass of potassium chloride, excuse me. And the way to read this is that in 100 grams, right, in 100 grams of this solution, you are going to have 5 grams of KCl, and you are going to have 95 grams of whatever your solvent is, which, again, we've just been assuming water the whole time, but it's probably a safe bet. But it doesn't even matter whether this is water or not. Like 5% weight to weight means that 5% of the weight within there, 5% of the mass in there is potassium chloride. So if we have a sample of 100 grams, 5% of 100 grams, right, which is 5 grams, is going to be potassium chloride. So to make this up, we would measure 5 grams of potassium chloride and 95 grams of our presumed solvent identity here, which is water. So hopefully that was a easy crash course through solvent or solution preparation.